Excellent, thank you. Is this working? Okay, cool.
It is.
Excellent. Thanks for showing up. I appreciate that. This is Econ 101. So please open your textbook. No, I'm just kidding. Excellent. So I'm probably not going to do a lot of talking just because I'm sick. So it's going to be more Solal today, but I'm just going to kind of kick us off. So start off just with our agenda. So I'm going to kind of set the stage for kind of how we collaborate together. And so our two companies kind of fell into a little bit of a partnership with each other. And so we had a customer that was using GraphQL and using our product in very interesting ways that was providing a lot of challenges, we'll say, for our teams, especially from the security perspective. And so then we started, needing more security on our end, so we decided to go out and find a product that we wanted to use for monitoring, which just happened to be the same company that we were trying to surface. So anyways, why is this not working? So in the theme of better together, we decided to do a little bit of a collaboration between our two talks. This is not working. So ignore the AI generated images, but so how a strong cross-functional relationship enhances the partnerships between companies is increasingly more important as the security landscape changes. And so when you're talking about security as a layer, it's not just a layer, it's more of a collaborative practice. And so it's built into every aspect of our development and operations at this point. So when we're talking about security in modern architectures, obviously GraphQL allows for for flexible queries, but it increases complexity. And so that makes security oversight exponentially more critical. And so securing cloud-based infrastructure and code, kind of what Wiz manages, is essential to protect your data and your services. So when we start talking about a cross-functional relationship, developers, security engineers, operations teams, platforms teams, you name it, they all have to work together in balance. And so especially when you're talking about innovation and security. A strong relationship ensures security is integrated from the start. The whole shift left narrative, I'm sure you've all heard of that. Apollo and Wiz together kind of help your teams be the most confident in your deployments. And so making sure that you don't have to worry about what you're deploying is going to be insecure or it's going to be a problem for you in the future. Okay. So I thought I would just do a little shout out to GraphOS. It has a ton of security features right out of the box. Some examples: field level authorization, schema validation, persistent queries, safe listing, rate limiting, etc. SSO v2, shout out to our identities team. Also, we kind of released this year. But there's a lot of scenarios where maybe those out of the box solutions don't work for you. Maybe you need to extend some of them. So we have a lot of options, and Router is really extensible when in the form of coprocessors or some other things. So I wanted to, dang it. So I came up, well, I didn't come up with this term, but I thought the term co-innovation was really, it described kind of the working relationship between our two companies. And so as Apollo builds new development tools, new features, it requires robust security to ensure that the products it releases are safe for its end users. This means that not only do users benefit from leveraging both Apollo and Wiz together, so does Apollo and Wiz. So it's a little bit symbiotic in that way. So as an example, Apollo's schema registry helps automate deployment pipelines, but if that's not secure, then that's obviously a problem. So Wiz actually provides a lot of that security and gives us a lot of confidence there. So, yeah, on the flip side, Wiz obviously relies on schema registry to ensure reliability, visibility, scalability of their managed federation. Thank you. So, as I was saying earlier, even with all of the robust feature set that Apollo or GraphOS brings, sometimes there's going to be some scenarios where maybe you need to think a little bit outside of the box. So I actually think this is a good time to introduce Solal, CTO of Enterprise Solutions over at Wiz. Wiz is such an amazing company, I thought I would actually just do a little plug for them. They achieved unicorn status in a record time, I believe, with an evaluation of over $1 billion, and I think it's well over $10 billion now, in less than a year of launch, which is amazing. And they've achieved countless recognition awards. I think they were named leader in the InfoSec space by Gartner. Anyway, so yeah, Solal.
Thank you very much. Can you hear me? All good. Thank you very much. So just a little bit of a recap about what Wiz does and who we are. Wiz is a cloud security company. We work mainly in public cloud, but also hybrid cloud when it comes to securing your workloads. We are currently trusted by more than 40% of Fortune 100, and among them, the largest cloud environments in the world. We span pretty much all of the industries out there, from tech companies, regulated financials, healthcare, and pretty much every industry in between. And we're also very proud to be rated as the leader of cloud security based on customer satisfaction. So what we do is basically give organizations, when it comes to securing their cloud workloads, a unified approach for cloud security, starting by prevention, risk assessment, all done agentlessly to prioritize your risk in your cloud environments, and to find the attack path and fix them. And as part of the platform, we're also giving the options to shift left your entire pipeline, shift left your security, make it as part of your development instead of your afterthought to come back to fix later, and as a preventative approach. And then all the way to runtime and runtime detection and response using the last line of defense of a very lightweight agent, which we call the sensor, to provide and correlate signals from runtime to deduce and acknowledge what we found based on the risk assessments. And just to give it's really hard to describe a platform that big with one slide, so I'm trying to do so with one GIF about the cloud security operating platform and how we can prioritize attack paths.
There you go.
Yay. It'll only play once, so we can go back and do it again. Thank you, Google Slides. But basically what we do is prioritize the attack paths based on scanning your entire environment, putting them all on one graph so you can correlate the risks. Thank you very much for the replays. Correlate the risks and, and see what's most important for you. Now, back to our journey and talking about the graph. We had quite an interesting journey choosing a tech stack when we started 4.5, almost 5 years ago. And we chose our components and how we build them. I'll also talk about migrations when it comes to choosing your right stack, but also being able to move later if you need to. But one of the pieces we chose for our stack is Supergraph on day one. We had some shifts along the way, some migrations we were ought to do, like starting with gateway, hyper-customizing our environment, barely using any GraphOS features, even when they existed, but we started before they existed, and recently moved to router as well. So we had a migration a few weeks ago, actually, to move to router and the durability, the flexibility, performance improvements, and what we can do with extensibility there compared to the old way. And we pretty much started and continued like that with more than 4 years of building on GraphQL. Historically, we've made a lot of wheel inventions, not really, but features we really wanted to be more specific to our environment that GraphQL didn't have. And that's basically for 4 years since then, we have a lot of engineers in the back office in Apollo that are saying, that's Wiz again with those spikes. And we had to do all of those wheel inventions based on how we wanted to create our infrastructure. We are very hyper-customized, we are self-hosted, we are running our own code on top of that. And we are also, from day one, started a path towards regulation, towards FedRAMP certification. So we also needed to think about, from day one, what we need to do with GraphQL to make sure that all of the audits for FedRAMP will be met. And that was a journey on its own, and we became FedRAMP authorized very recently. What also took front and center as part of designing our journey was custom RBAC, custom router, custom asterisk, pretty much. Mainly because we saw the power of the platform, but a lot of moving pieces didn't exist as we started. So we needed to do some migrations as time passed by a lot of conversing with Apollo on what are the features we are creating so they can then go and benefit everyone and also develop out of the box so we can also move. So that was and still is a very interesting journey, I must say, on how we can do better and achieve better. But we don't have the kind of challenges other organizations might face of having more disparate APIs with different backends and trying to incorporate REST, which is super cool these days with connectors. But we have a different set of challenges that we are always solving because we started SuperGraph day one. Thank you very much for Gen AI for all of the images, but let's talk about basics. API security in GraphQL. And if we need to recap one by one, just to make sure we do some scene setting, authentication. In a nutshell, it's when or who someone comes to the platform. It's showing your certificate, showing who you are, and letting you in. It's determining if the user is logged in, and subsequently determining who you are. Authorization is what can I do or see. Once I'm in, it doesn't mean that I'm allowed to do anything. We have a corner case for letting partners in while not being able to do anything because we just want to give them access to our gated docs as they build integrations. So they are being authenticated, but they're authorized to do nothing. So just as an example. The methods to achieve authorization are pretty much endless anywhere, but also in GraphQL. You have a lot of ways you can do authorization. Some are common, some are less common. The methods vary all the way from JWTs, from Java Web Tokens, JSON Web Tokens, to directives approach, or using any custom RBAC, creating your own roles or permission scopes, to any custom logic you do solely in resolvers. We chose to go with the JWT approach. One of the reasons is also around the fact we don't do our own authentication. We trust on a third-party IDP to do the authentication itself, and we only use it as a service, and we don't want to do what somebody else does better than us. That's, in essence, most of our approach when it comes to the platform. I don't want to reinvent the wheel unless I have to, and make the platform better by porting it back with feedback to the product. So that's also how we started when it comes to JWT and permission scoping for RBAC, which I'll touch more on the directives. Router. Router has many attributes to it. It's very fast, very efficient, it's very performant, and it also gives you a lot of ways to do guardrailing. So putting some limits in, putting additional security checks, putting additional logic for tainting or attributing that you want to do for monitoring. And that's very cool, especially with all of the co-processors, which we'll also elaborate on. But we didn't start that way. So I talked about the journey and how we started building features and moving to what Apollo GraphQL does offer out of the box. Router is one of them. So we only moved to router in production about a month ago. For 4.5 years, we were using Gateway. So it was challenging on its own and fun on its own, but super, super tedious. So we are very happy about the move because now we have so many doors opened up again to do more features and then feed back to the Apollo guys. Federation. I think pretty much everybody here, even if you didn't know what federation is after the last couple of days, you do know about federation. And it is the central place for all of the security checks as well. It's not just about performant APIs and being able to parse all of your queries and how they're being built, but it's also there for your central security checks. So Federation is natively offering it. It's not something you really have to do from scratch, but it gives you the flexibility to not go around and do it in many places. It's also your central location for initial checks. Security at depth is an approach I really believe in, and while you can just count on Federation to do your security, it's always beneficial to do it at depth. So you start at the Federation, you make sure the RBAC method you chose is enforced, but then you also do it down the line in the microservices, in the subgraph, in the backend, to make sure that no microservice service trusts each other. But the first and foremost place where you start is via Federation. So the authentication, the authorization, that's your, sorry for the pun, gateway, because it's not a router. But that's your initial gateway for the product via the router. Rate limits, again, there are many ways of doing rate limits, but as part of Federation, you can do different kinds of rate limits. You can do rate limits for the entire tenant that owns, that bought the product from you, and you can also do rate limits based on the entity, based on the user, or even based on the environment. So you choose based on which graphs you publish and which environments you have, and you can do different kinds of rate limits. Let's talk about some very high-level best practices, and we'll go again via the order of authentication and authorization. So first and foremost, about authentication and authorization, I can't stress it enough, but make sure that the requests you have for the supergraph are authenticated. Check it even twice or thrice. There are not enough times where you can check that the user is authenticated and authorized. So check and check again, or don't trust anybody. It's the basics of the zero trust model. But always validate the authentication, especially if we're talking about a B2B solution and not a consumer product, which offers more e-commerce-like solution, then it's super important to do this double or triple validations. This could involve OAuth, API keys, or other mechanisms like we discussed, but make sure you do the validation. RBAC, when it comes to authorization, you can implement a fine-grained control access at the schema level, and that will restrict the access to certain fields or types. You can then choose the granularity where you do put the guardrails in when it comes to RBAC and doing granular permission scoping. You can do it all the way from saying, are you authenticated full stop, that's it, or go all the way down to which queries, which mutations you can access based on an access scope you have, and the access scope in our case would be signed in your token, in your JOT, or you can even go as many layers as you want in the input, like mix the permission scoping on your query. You can say a query to fetch data, you'll need the read resource for that data source, but in addition, for that specific filter, you'll also need another permission to export the data. So you can be very granular in where you put those permission scopes. Another best practice for security is query depth and complexity controls. Query depth, in essence, limits the query depth. It prevents overly complex queries from running by setting the max depth. That will help you with denial of services on your queries. Not necessarily classic denial of service by bad actors, but just by unknowledgeable users. So it happens a lot. We see it a lot. Jason sees it a lot from us as well. By misusing a specific API because you just didn't think of corner cases, you can DDoS an endpoint by mistake without being a bad actor. So setting these kind of query depths, as long as you know that the corner cases, the use cases for what data points you want to achieve from the API don't go beyond the query depth you put in place, then you're good to go. But if there are specific use cases for going deeper, that's the time to talk to your users and see why. But that's a good best practice for making sure, like rate limits, that you make sure that the API is working, it's performant, and there's no bad neighbor syndrome in your data center. Rate limits, we touched upon it, we brushed upon it, but rate limiting is super important when it comes to making sure that there is no bad neighbor syndrome, but there are several ways of doing so. As I mentioned, entity level, tenant level, data center level, or different between environments, because your demo environment needs to have a very high rate limit so many different people can show your product. as they sell, but in production, there is a different limit. If it's a customer paying for their own data center, they have a higher limit because there's no bad neighboring syndrome. It's only them. So the flexibility to do so and the importance of doing so is key. Session limits is a new thing we discovered as part of our FedRAMP journey. Some regulations also mandate that you have to do session limits. So you log in once, you can't log in again from a different laptop. In any other environment, it's not a requirement, and it's fine to do so. So session limits is one other best practice when it comes to regulations. Schema and operation security, regularly validate your schema. Even if Apollo comes back to you and asking, why are you checking your schema for so many times? And believe us, we know. The reason why I'm saying it, even if you have a very small supergraph, dozens of supergraphs like we do because of the different environments, it's super important to make sure that there is no unnecessary sensitive information that might bubble up. All of that will come back into the directives approach, which we'll discuss in a second. But even validations of sensitive data by writing unit tests to see that decorated types that are with sensitive information always show redacted data, it's part of the checks, it's part of the validations you can do. So testing it and continuously validating it is super key. And operation whitelisting. Classically, I guess you already heard in the last couple of days why operation whitelisting is beneficial. But there are other use cases for why you would do so, not just to obfuscate APIs from users, but as another alternative and approach for feature flagging, for giving customers their own access to features before you roll them out. There are multiple ways you can use whitelisting, classic reasons and other reasons. I mentioned zero trust a couple times. Zero trust as a definition, as a solution, has so many different ways of expressing what it is, and each person on Earth has two different opinions, so now calculate how many different zero trust models are out there. For us, the idea about zero trust is it's secured by design. Nobody has access to anything unless explicitly said so. So you have to be authenticated as a paying user. The second thing is you have to have the right permission for the query or mutation or the part of the type. If you don't, then by default you'll fail. And it's always an explicit opt-in. So for us is trust no one and give them the actual permission you need as part of your role building model. Let's talk about do's. Usually these kind of slides talk about do's and don'ts, but I'm trying to stay positive. And let's talk about some authentication do's. First one is implementing a robust authentication strategy. A part of it is finding the right solution for you based on how you built your authentication part of the platform. Authentication is a platform on its own. Whether you build it or whether you use an external IDP and you wrap around it. So based on your needs, it's very important that you build it robust with high availability, DDoS protections, and making sure that you do it properly so there is no downtime or data leak just because of the authentication strategy. Because eventually, even if all of the product works, but your authentication strategy doesn't perform well, then your product is down. It doesn't matter that everything else is functioning. It's the entry point for the user. So make sure you have a robust authentication strategy. Use industry standards. In this case, try to not use any novel ideas. Use trusted and vetted ways of authenticating or using JOTS or Auth for your authentication. And always, always, always validate. So especially if you're using an external IDP, continuously validate. So make sure that the key is there, that you trust it, that you handle the validation on each and every level, both on the router, both on the subgraphs and the backend, in each microservice. It's super important to do the token handling and validation on each and every action that is made. Some more do's. Authorization in the router. The router is very powerful in the logics. You can use it for the authorization. So as we move from gateway to router, we had a very easy approach on implementing authorization based on the claims and the endpoints that we have. and inside the claims, the custom authentication directives that we have. And on top of that, with coprocessors, we added the additional best practices we needed to put in place, like the rate limits, the session limits, the obfuscation of data. We use coprocessors to plug it in and not customize the code like we had to do in Gateway before. And authentication endpoints. You have to make sure that you properly secure them. They are the single entry point for pretty much all of the users in the data center or in the website that they're accessing. So they need to be basically closed down as much as you can, that they're only served based on the key or the token that you trust with. Authorization do's, and I'll brush through these a little bit faster and apologize, are back. Simplify the router. Keep the router as clean as simple. Unlike Gateway, that's one of the reasons we moved to router. It's clean. We don't need to touch the router. It's basically pretty much as is. We trust it. We wrap around the router, and we plug coprocessors to it. So keep it clean and simple, and manage your custom groups of scopes via your application. Send scopes on your JSON Web Token. Fine-grained access control. These days, after we are smarter, require scopes as a directive exists. When we started, it didn't. So we created our own directive. We smartly called it Auth, which now is default. We called it Auth, and it works sort of like require scopes. But the idea behind it is it doesn't matter if you use a native solution from the directives as an example that exists or a custom solution that you provide. It's very important to always keep up, always validate with your teams at Apollo on as the features progress, because that also made us move from Auth to require scopes instead of reinventing the wheel again. The wheel exists, let's use the wheel. But using either one of them, you can do granular access control. Also be granular with the directives. Directives are sort of like tokens in a casino. It's fun to start throwing them away and use them as many as you want, but be cautious with it, but also be granular with it. When you do use them, they can be as granular as you need, from the schema all the way down to the different tiny inputs. So when you use them, make sure you use them granularly, and if you need to create your own for a reason, like obfuscation, the sensitive data access, authentication controls before require scopes existed, make sure you feed it back to Apollo. They care, they want to put it as part of the native feature sets, make sure you feed it back to them. And as we saw along the way, a lot of these actually were implemented. Directives. This is our director. He directs traffic, as you can see. Directives are super fun. They are basically annotators, or how our developer calls it, decorators, to modify the behavior of a query that is used to enable the conditional logic, apply transformations, or enforce rules on your schema or query levels. So they're super fun to use. Either custom ones, again, like we used for Auth before require scopes existed, deprecations of APIs before you break schemas, even though you shouldn't, or requires or provides for migrating data between subgraphs, or even using local cache for information that you don't want to wait for data access. The router, I already touched coprocessors, but router is very powerful when it comes to coprocessing. Make sure that you use it for your use cases for customizing your environment. So rate limits is one example. Customizing it per entities or tenancy. Session limits that we mentioned for federated environments, for FedRAMP, for example. Make sure you use the power of the router and its coprocessors for your bespoke solutions and for the access that you need. Supergraph, as we mentioned, we started it by design from day one. And for regulated environments specifically, we don't have a supergraph. We build it compose it as one huge graph, because that's what the audit also requires, which is a downside, but we can do so. It's something that we're very happy that we can do with GraphQL, that other solutions don't let us do so. So it's something that is doable. It's not as easy to do, but it's doable. Okay, some recap. case studies, best practices, and some real-world examples for API implementations. Custom authentication, bespoke directives, you can do so, you can use them. If there's something not out of the box, use the power of the router and the platform to create your own directive, create your own bespoke solutions, and use them, provide the feedback. Federate authorization, trust no one, trust no subgraph. Always check it on the router, the subgraphs, and your backend. And experimental APIs. Don't be afraid to do so. It's fine to use experimental APIs. There is a reason why you would do it, even in production. So if you need to, there is a way to do so. So it's also something to consider and remember that exists. So you can do it as well. And some lessons learned. Native features, use them wherever and as much as you can. Use the power of the platform to customize any bespoke solution you need, because you can do so, but don't forget to provide the feedback. Apollo wants to build it better. Run self-hosted wherever you need or can, like in our bespoke solutions, and migrate. It's fine. If you need to migrate, there are classic ways to do so. There are very novel ways of doing so. You can migrate. So don't shy away because you took a decision 5 years ago of using a solution, and now you have to be stuck with it. So even a migration like we did was using canary testing, using different deployments over a few weeks. Nobody knows that the change happened. It works as it worked before. So migrate. It's fine. So thank you very much. We're still here for a few minutes if you want to discuss some QR codes or company profile or my LinkedIn profile if you need to. You can take a picture. And thank you very much.
Yeah. Thank you.